Hi everybody, thanks for coming. Today, as Dan says, I will be talking about how we built the Google Wave client with Google Web Toolkit. And what am I going to be talking about? Just in case you forgot what Google Wave looked like. Here's all of the functionality. We've got abuse detection, safe searches, folders, authentication, playback, lots and lots of features. It took 80 minutes to demo it last week, and I'm not going to demo that all now. Today I'm going to talk about our decision to use Google Web Toolkit, and this dates back to 2 years ago. It was a fundamental decision, and I'll tell you why we think we made the right decision. I'll give you a very brief insight into the architecture of our client, some of the changes that have occurred in the Google Web Toolkit over the last 2 years that have made our application not only possible to build, but also easy, a joy to develop. I'll talk about how over the course of developing this application we've improved gears, and we hope to work with the HTML5 committee to improve, to get file drag and drop and all of this extra functionality that you can't do in the browser today. And we don't want to be restricted by the browser today. I'll talk about performance. It's pretty fast. We need to make it even faster. And I'll tell you why we think performance is important and how all the work that we've done to make it feel really fast. I'll show you the mobile client again in case you missed it this morning. And I'll talk, since we're all developers here, I expect, I'll talk about testability and why testing is very important if you're writing a big web application. And I'll tell you about a tool called WebDriver, which has been critical to the success of building the Google Wave client. Okay. So what are the requirements of the UI, the user interface for Google Wave? It needs to be fast. We want it to feel like a desktop application. It needs to be visually stunning. If you've used Google Maps before, you'll know that the creators of this, the founders of our project, they're very big on things looking amazing. And do the people in the audience think Google Wave look pretty good? Yeah. We like to think beyond the browser. When we started this 2 years ago, we made a conscious decision. Let's not target what we can do today. Let's think what will we be able to do in the browser 2 years from now. And we've been aggressively pushing some functionality, and we didn't want to be restricted by what we could do. And a principle which we like to call on our project optimistic. Our user interface uses what we call optimistic UI, which means when you as a user click a button, you don't need to wait for the server to acknowledge your request. We want it to be possible that you can keep working and in the background the server acknowledges things. This allows you to keep moving on with your work, write more waves without constantly having to wait because you have a slow connection. We call this optimistic UI. And I'll just very briefly, I'll show you some of the cool things that we can do. Just a few things that I don't think have been shown before. And that's Google Blue Screen. So here I have the Google Wave client. And we've seen that on top of all the functionality you've already seen today, there's very quick resizing of panels. I can drop this down, I can click on it, I can open my inbox from here. There's another feature we think is kind of neat. You can have more than one wave open at the same time. So while we're talking about a map, I can be chatting with one of my other friends at the same time. Drag drop of photos, you've already seen that. I can drag Andrew into this chat if I wanted to, but I don't want to. Okay, so that's just some of the cool stuff that we put a lot of effort into making the UI feel more like a desktop application. Drag and drop is gradually becoming more popular in web. Okay. So very early on in our project, we needed to decide whether to use the Google Web Toolkit or not. We initially were a 5-person team. It was the two brothers who made Google Maps, and I was one of the people in the 5. And we were a bit confused. We actually wrote our client in Java, so Google Web Toolkit, and our server in JavaScript, which is the exact opposite of how you would normally write a web application. So first I will tell you what Google Web Toolkit is, very briefly. You write in Java, and it compiles down to JavaScript. So it's just, there's no ActiveX or plugins or Java, this, that, and the other. It still runs as JavaScript. And it compiles your code down very optimized, so it should actually run faster than handcrafted JavaScript. One advantage of this is you can use your favorite IDE. So I use Eclipse, but some people use IntelliJ. Instead of having to use Vim, Emacs, or your favorite text editor, you can now use a powerful tool. Welcome back to the modern age of software development. Another cool thing about this is you can share code between the client and the server. We wrote our servers in Java, we wrote our client in Java. So we have entire libraries. So you saw earlier today that 2 people can talk at the exact same time on a wave. The library that allows the concurrency to happen is actually compiled into the client as JavaScript and compiled into the server as Java bytecode. So we share code. We didn't want to have to write everything twice. So it saves us a lot of time. Very cool. Another property of Google Web Toolkit is deferred binding. And so this is a tool of Google Web Toolkit that lets you, at compile time, determine what code should be sent to the user. So what this means is Internet Explorer users will see Internet Explorer specific code. Firefox users see Firefox specific code. Safari users, you get the point. So instead of sending down JavaScript that on the browser, sending it down to the user that says, if Firefox do this, if Internet Explorer do that, we figured out very early on when they load the program, hey, you're using Internet Explorer. Here's the Internet Explorer version of Google Wave. And we can also serve you the correct language. We can detect that you've got gears installed or not. So it allows for the code to be a lot smaller, compiled down. And the last concept I want to briefly introduce, because I will be talking about it later, is JavaScript native interface, or as the Google Web Toolkit team calls it, JISNY. And JISNY allows your Java code to talk to JavaScript code. I'll show you an example of this later, but if you ever find that you just can't get it done, what you're trying to do in Java, you can write a little bit of JavaScript. This allows you to interact with other JavaScript on the page. So, for example, the demo that David showed with embed, you can see a wave on a page which is talking to the outer page. Also the ORCID demo, we use JavaScript hooks from the Java to communicate outside the page. Okay, so that's very brief introduction to Google Web Toolkit. As I mentioned, the history of the project, we demonstrated a prototype to our CEO and our founders, late 2007. And my background, I used to work on Google Maps, and I love JavaScript. It's a great language. I'd become very good at it, if I am allowed to say so myself. I didn't want to use Google Web Toolkit. There were a lot of things that just weren't ready. It took a lot of convincing. And in the end, Bruce and Joel, the leaders of the Google Web Toolkit project, they flew all the way from Atlanta to Sydney, and they said, oh yeah, we know about that. We're going to do that. We're going to fix that. We're going to do that. We don't like Java either. You know, they sold us on Google Web Toolkit being a really powerful tool. It speeds up development, and it produces faster code. It's not that Java is the coolest language on the planet. And you know, some people like Java, some people don't. I am not a person who cares too much what language I'm using, as long as I can get my job done. Also, a previous myth about Google Web Toolkit is that you can't build a real application. We like to think that we've managed to build a real application with Google Web Toolkit. And a last point is we feel that using Google Web Toolkit has helped us change our mindset. instead of constantly thinking, what can we do? We think, hey, I want to do this. And then we worry about that. It allows us to think somewhat at a higher level. We're not constantly worrying about bugs in the browser. We can now think at a higher level of abstraction. So obviously we decided to use Google Web Toolkit, and I'll show you some of the things that have changed. A brief look at our client architecture, very brief, just some pointers. At the bottom of our communication stack, we use a bidirectional communication channel. For those familiar with XML HTTP requests, we use what's called a hanging get. So instead of constantly having to make a new connection every time we want to send data, we keep a channel open, and it works both directions. And this allows us to get things fast. Also, we use what's called a protocol compiler. Google has open sourced protocol buffers, and that's how at Google we pass around data everywhere. Protocol buffers are just the way we describe the data that goes around between all of our different services. And we use this to talk between our client and our server. So we made a custom version of this compiler, and so we define a Java interface for all of the messages that we send between client and server. And from this protocol buffer, we generate a Java interface, a client-specific implementation, and a server-specific implementation. On the server, we want to pass around protocol buffers. That's how Google works. On the client, we don't want to have to pass around big, bulky data objects. It would be too slow, use up too much memory. So we use what's called a JavaScript object. I'll talk about this later. Which actually is very lightweight wrapper around JSON. So because we're using Java client and server side, we can generate client and server implementations and write our libraries to talk only on the interfaces. So our concurrency control and our transformations and our representation of our data objects manipulates interfaces rather than caring about whether it's on the client or the server. We also, at a very high level, we have a concurrency control stack. So the editor, when you type, generates operations. So Adam typed the following word, gets sent along the wire. And this gets represented in this fashion, and we have a very interesting algorithm, which you can learn more if you go to wave.google.com. There's a video about how we do the concurrency control. And also, David just talked about Wave APIs, how you all can extend the client, add gadgets, add extensions. If you missed it, it's on YouTube. And also a talk from Google I/O from last week, which is called Under the Hood, which explains all the magic. It explains concurrency control, it explains how the editor works, and it also explains the spelling, how we did the spelling demo that you saw. Iceland is an Iceland, becomes Iceland is an island. All of this is talked about. I'm sure you're all curious what browsers we support. Currently, we support Firefox 3, Safari, and Chrome. And in development, and we've gotten very far, I'm sure you saw our Android and iPhone is quite good, but still we have a lot more work to do before we think it's ready for usage. And also Internet Explorer 7 is under development. This is all made very easy thanks to Google Web Toolkit. Google Web Toolkit takes care of most of the cross-browser issues. Only in the editor, which gets really intimate with the browser, intercepting keyboard events, etc., do we actually worry about this, and even that is quite a small library. So Google Web Toolkit makes cross-browser easy. And also, if your favorite browser isn't listed here, don't worry. When we have time, we'll get to it, and it shouldn't be too hard. I'd like to talk about the evolution of the Google Web Toolkit. So I mentioned when I started using Google Web Toolkit, I wasn't a huge fan. There was a lot more work to be done, and I needed convincing. So let me tell you what the problems were at the time. So the areas for improvement in late 2007, user interface, the code is cumbersome. It takes a lot of code to create panels and widgets and this and that. Cross-browser CSS. Turns out that GWT is brilliant at abstracting away quirks of the JavaScript, but a lot of the quirks come from the CSS. this was an objection I had. Note that these are all objections I had in 2007. I'll tell you how they've all been addressed. The JSON handling is heavy-handed, so we create memory references in the client, and so slower to run, more memory. The debugging environment isn't the browser, so sometimes you'll have a bug that occurs in the real browser, but doesn't occur in your debugging environment. Makes it very hard to fix. Google Web Toolkit uses a concept called a monolithic compile. What that means is it compiles your application into one massive JavaScript file. The problem with that is everything gets downloaded at the start, and as we keep adding more features, our program gets larger and larger, and it takes longer to download, and our poor users use dial-up. They take far too long to get to our application. So we wanted that fixed. It wasn't clear what the mapping between the Java and the JavaScript was. We'd like to know, why is the JavaScript so big? Is it this class or that class? Just out of interest, a quick show of hands. Who has used the Google Web Toolkit before? Excellent. Well, by the end of today, next year when I come back, you'll all put your hands up, please. Another problem, inefficiencies in the compiler. We felt that it could do a better job of getting rid of code. Okay, first point. So what you're looking at here is what Google Web Toolkit UI code looked like back in 2007. It's a lot of work. You've got to write Java code, imperative, create new div panel, add a label, add a radio button, add a text box, an image, hook it up together, make the events work. Turns out there's a perfectly good language for writing UI code. It's called HTML. So why don't we use that? So that was an issue. Aha, fixed. So now there's UI binder in Google Web Toolkit, which was formerly called declarative UI. So here's an example, and you can see it looks a lot like HTML. It's actually XML, and the reason we do that is it allows special little hooks to talk to our Java code. So you can see we have a div hello name, and this span UI field that actually hooks it up to my Java code. Magic, done. A field called namespan. So now I can call get namespan from my Java. And what's really nice is because this looks like HTML, our UI designer who doesn't write Java code can now fix up our whole UI. And this presentation will be made public, so if you want to click on all the links to learn more, please do. But most cross-browser bugs are CSS. So Git abstracts away the JavaScript quirks. We have an Internet Explorer, deals with those quirks, Firefox, etc. But that didn't help with CSS. Sometimes the different browsers handle CSS differently. The solution to this, style injector and CSS resource. So now from my Java code, I can inject a CSS file. And what do I get? Why do I want to use this? Well, firstly, validation. So in case you're wondering, a really cool thing about Google Web Toolkit is you get compile time errors. So while I'm writing my code in Eclipse, I get red squiggly lines telling me I made a mistake. If you're a JavaScript developer, you're probably used to getting errors when you run the application. So you find the bugs much quicker, saves you a lot of time and, more importantly, frustration. So we get validation. Our CSS, it actually checks that we correctly spelled the class names. Minification, so all of our CSS class names get reduced to 1 character or 2 characters. Makes the download smaller. Image spriting. Many of you might know that we can't download many images at the same time in a browser. So image spriting takes all of our images and packs them into one image and handles this automatically. The client correctly places the image. This one I particularly like as a lead of the client team. We've got a lot of people writing a lot of code. It allows modularization of the CSS. And what does that mean? That means that I have a search panel package, and I can put all the CSS in the search panel package. So we used to actually have one big CSS file which was 4,000 lines long. And nobody on the project knew how it worked. It was unmaintainable. Now we can put the search panel CSS with the search panel, the mobile CSS with the mobile. And now it's much smaller CSS files located near their code, very easy to use. And what's nice about this is now CSS gets downloaded only when it's used. And as I mentioned, the cross-browser quirks, we can now, if we want to, have different CSS specifically for a browser. And this code sample shows if user agent Safari, add this rule, WebKit border radius. So how many people in this room have torn their hair out, spent a week trying to chase down why this one bit of CSS worked great in 9 browsers, but not the 10th browser? Anyone? Okay, not as many as I'd expect. I used to chase down the bugs in the one browser. Now I can just special case it. Great. Inefficient JSON handling. Previously, JSON used to be handled, you had to create objects and copy the data from them. The Google Web Toolkit team came up with a very nice solution called JavaScript Object, or JSO. So what you do is you subclass in Java, you subclass the JSO to create what's called an overlay type. And the compiler, very clever, it figures out, JavaScript object, and it inlines all this. So every time you call a method on a JSO, you don't actually have extra code for it. So it's faster and it's quicker to download. And here's an example. I mentioned GDD earlier, JavaScript native interface. You'll see this method here, it says native. It's actually JavaScript, these methods. So the bits in green are JavaScript, whereas everything else is Java. So I can call the method setPayload, and wherever I call that from my Java code, when it becomes JavaScript, gets inlined completely, and so great, saves us download. Next problem, debugging in Eclipse rocks. It's great, but each browser behaves slightly differently to hosted mode. Previous version of GWT, if you had a Linux machine, you could only debug in Eclipse on Firefox. Mac, you could only debug on Safari. Windows, you could only debug on Internet Explorer. But I don't want to put Eclipse on my Mac. I want to only develop on my Linux box. Out-of-process hosted mode is the answer to this. And instead of having this previous problem, I now install a plugin into all of my browsers. Very cool. So now I can actually debug in my real browser, but step through the code in Eclipse. So I step through the Java, but what's running in the browser is exactly what I want to see. And so how many JavaScript developers in the room? Yeah, a few? So the JavaScript, when you're debugging an application, you use Firebug. It works great in Firefox, but it doesn't work in Internet Explorer or other browsers. So it takes a long, long time to find your bugs. Whereas out-of-process hosted mode, or UFM as it's called, allows you to debug in all your favorite browsers, and we've even seen a demo of being able to debug on the iPhone. So I step through my code on my Linux machine and see it work on the iPhone. Very cool. So I'm going to show you how this works. Okay, what you're looking at here is Firefox. This is the real Firefox, no tricks up my sleeve. It's got the GWT plugin installed, the hosted mode plugin, and you'll notice, ignore the fact that no waves, no contacts have loaded. I'm going to show you how we develop, how we debug in Google Web Toolkit. Let me quickly connect. Now you all know my password. Dot, 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 dot. And what you're looking at here is, this is actual Google Wave code. Okay? We call our project Walkabout, if you're wondering. That's our internal code name. So this is actual Google Wave code. And welcome back to the IDE. I can do all sorts of cool stuff. I can click this and find out what it was. I can refactor. I can develop easily, quickly. It's great. Now I've set a breakpoint here. Okay, so this is actually a machine sitting in the office at Tsinghua Science Park, and my Firefox is sitting on my laptop right here, and I'm about to debug using the Eclipse session on a different machine connected. So, wish me luck. So, I've set a breakpoint on search. So when I do a search in this box right here, so I'm going to press enter. First thing you'll notice, the browser freezes. So this means, aha, the debug hook is there. And you can see, great, we've just hit that breakpoint, and I can inspect the values. So I can look at my variables. Aha, this is box, and it's got this HTML code. It's not a. I can look at all the values, inspect it, find out what's going on in my Java code, while debugging in my real browser. Very powerful. So I'm going to step through. So let's step, and there you go. That's how we develop. So Eclipse on one machine, and I can debug on Firefox on my Mac, or any browser, really. So we debug in Internet Explorer using this same plugin, all from my one browser, my one Eclipse session. So that's out of process hosted mode. And I'll just point out, you're all very lucky to have seen that demo, because it did not work last week at Google I/O. So consider that a world exclusive. Next problem. Are we going to distribute Google Wave as a CD-ROM? It's very big. It gets bigger and bigger and bigger. The bosses of Google Wave, they love adding new features. You probably saw the demo, and we had 300 features. Not enough time to show them all. So every time you add a feature, the code gets bigger. The problem with that is, as the code gets bigger, your users have to download this JavaScript code. They have to download more. And if they're on a dial-up modem, it takes longer. We don't want people to have to wait a whole minute before they can use Google Wave. We want them to be able to use it. Start it up, get using it. This is an actual graph of the size of our code increasing. And if I can get this little laser thing. This number here is 1 million bytes. 1 million bytes, if you do the maths, think how long that would take to download over a dial-up connection. That's before we do gzipping, so it does get compressed, but still, up and up and up. The more features we add, the slower it gets. You want it to get faster, not slower. So we didn't want to have to throw away any features, and we obviously didn't want to have to hand out a CD-ROM in your bag at Google Developer Day. Here's Google Wave. We like the web. So Google Web Toolkit team invented run async. What's run async? Run async is a command to the GWT compiler, very easy to use, that signals a cut point. And it means you can download what you need when you need it. So when you're using Google Wave, you don't want gadgets code if you haven't used any gadgets. You don't want maps if you haven't used maps. In fact, if you haven't even opened a wave, you don't want the wave panel to have loaded yet. You want everything to load just in time for when you need it. So another cool thing Google Web Toolkit throws in for free is, as I mentioned earlier, we can now associate CSS with individual classes. So our resources, the CSS, the images, the messages, all get downloaded only when they're used. So great, thrown in for free. And best of all, it's automatically handled by the GWT compiler. We don't need to think too hard about it. And you'll see this example here. This is, I think this is actual code. When you click the new wave button, we have gwt.runAsync, and inside the onSuccess method, wavecreator.createNewWave. So by merely guarding this piece of code with run async, the compiler goes, aha, you want that to be in a separate JavaScript file, which I will download automatically when you need it. That's all we needed to do to get waves to download on demand, asynchronously. So we love simple. Makes our jobs easier. So what did it look like after we did this? Down. We're very happy to see it didn't just keep going up and up and up and up. So this is our first attempt at hooking in run async, and this drop is our second phase of adding run async to the client. And you can see we've got it back down to, I think, I'll show you in a moment, but we managed to get our client down to only a couple of 100K. We still want to get that even smaller still, because if you do the maths, it's still going to take you a while to download. So we want less code to be downloaded faster that way. So thank you, GWT team, for inventing run async. This last drop here, which you can see halved the remaining client size, I'll talk about now. So now that we got it down after using run async to about 500, 600K, which is still too much, we want to know how to get it down even further. But we don't know why it's so big. So we needed a tool that would tell us where is all the JavaScript coming from. Story of your compile reports is Google Web Toolkit's answer to this. It's a report that shows you the breakdown, the relationship with your Java and your JavaScript code. And it's already helped us identify where problems are coming from. It helped us identify that the messages, the code for the messages going between client and server, are much too big. We also noticed the compiled class names appear in the code. So if you looked at our JavaScript a while ago, you would see com, Google, walkabout, search panel, and all the names of every single Java class included in our JavaScript. And if we had called our project W instead of walkabout, we would have saved ourselves about 40K of downloads immediately. What's in the initial download? We needed to know. We want to get the startup sequence very fast. And I'm going to show you what this looked like. The story of your compile, or SOIC, reports before and after. Okay, this is actual report for our project. And the story of your compile dashboard, first thing to notice is that the size of the initial download before was 347 kilobytes. And so if we look through this report, it tells us where all of our code is coming from. And this list here is a package breakdown. It shows in the top row the package that contributes the most JavaScript code to our download, and then decreasing order. And you can see the top line here is com, Google, walkabout, communication data. So we play a game on our team. We find whatever's the biggest, we find whoever wrote it, and we throw things at them until they fix it. We want to keep getting rid of the big code. And so this is what it looked like before, and I'll talk about how we got it down in a second. But after we fixed that, we managed to get it down to 179K, pre-compression. So this is great. The report actually helped us figure out what we needed to get rid of. Otherwise, we don't know what we're doing. We're just guessing. Maybe this will make it smaller. Maybe. This report really helps. And so now it's the GWT team's turn to help us get our code smaller. So that's a story of your compile report. Great. Next problem. So how did we get that last drop on the download size? So I mentioned we got rid of the communication data package. It was much too big and we got rid of it. So we used JSOs, these JavaScript objects which compile out. But before we could use them, we needed JavaScript objects to be able to implement interfaces, because our client code needed to implement the interface there. And why? The client and server use these common libraries, and they should not care if they're on the client or the server. So GWT invented single JSO import, which allowed it to be possible to have an interface. So thanks to that, we managed to halve our download size yet again. So to summarize what I've talked about, what's changed, why Google Web Toolkit is really powerful today. Declarative UI, so now I can write HTML code, get my UI designer to fix things up. Style injector, so CSS, easier to maintain, less bugs. JavaScript object, how do we get things to compile out? UFM, out of process hosted mode, which was me debugging on this machine here, but actually connected from Eclipse on a machine on the other side of Beijing. Run async, dynamically downloading code only when we need it. Let's get the initial download small. Story of your compile, where are the JavaScript bytes coming from? Single JSO import, and also the Google Web Toolkit team very kindly added a flag called disable class metadata, which got rid of the class names from our code. Saved us 90 kilobytes just like that. Okay, that's the Google Web Toolkit part of the talk. Now, some other things. Improving the user experience. We put a bit of work into improving gears. So you saw earlier today, dragging and dropping photos. We are now actively working towards adding this to the HTML5 implementation. Google Wave, we want to make the web better, because the better the web is, the better our application can be. So we do client-side thumbnailing. When I drag those photos, if they're really big, Google Gears actually creates a thumbnail, generates it on the client, sends the thumbnail down to the other person before the image is downloaded. So my friends can see my photos before they've even uploaded. Very cool. So we use a worker pool. We saw about web workers this morning in the keynote to avoid blocking the user interface. Another thing, desktop drag and drop. So that was using Gears. And resumable uploading. We want it to be possible. If your connection drops out, you plug it back in, everything still works. Performance. Google Wave must be fast. We don't want you sitting around waiting. And at Google, we know how important speed is. If we have 1 billion users, and we can make everything, if we can save one person 1 second, we'll save the whole world 1 billion seconds. This is how we think. So we want to save everyone as much time as possible. And we saw this on Google Maps, that we made everything much smaller, and suddenly people started using Google Maps more. We didn't tell anyone we had made it smaller and faster. It just, it was very popular. So how do we make Google Wave perform really fast? Firstly, we want it to start up quickly. How do we do that? Well, run async. I mentioned dynamically loading code only when you need it. Fast start, we send down the data with the initial download. So we send your contacts, your initial set of waves, your folders, so that you don't need to wait for the client to start up, send a request, get it back. Inlining images and CSS, so saving having to request images separately. We bundle it all together with the code. Smaller download, so like I said, getting that graph to go down is a good thing, makes it faster. We collect statistics. We want to know how fast everyone is finding it, and we monitor this, and if it gets really slow, we fix it. That's what we hope. And also recently we added server-side script selection. So I didn't mention this earlier. Google Web Toolkit, the way it serves Internet Explorer, the Internet Explorer version of the code, Firefox, the Firefox version, is you initially download what's called the sniffer code, and it detects it. It goes, aha, you're running Internet Explorer. I'll send you the Internet Explorer version of the code. We've now moved that sniffer to the server side. So when you hit wave.google.com, we, from the HTTP request, go, aha, Internet Explorer, here you go. So we save a round trip. So that's startup. Now once it's loaded, everything needs to feel fast. Waves need to jump off the page at you. So we use optimistic UI. I mentioned this earlier, that we don't block you on user actions. We want you to keep on working, writing waves, talking to people, without, even if it's not working, you should keep working. Prefetching, so while you're not opening a wave, we're fetching waves if we think you're going to read them soon. So if you're about to click a wave, aha, it's already there. Flyweight pattern, so for the developers out there, this is a trick used by a lot of applications now. Instead of creating objects for everything, we use a set number of objects, and when you scroll the panel, we reuse these DOM objects so that it's much faster. And we learnt some kind of interesting rendering tricks along the way. So I prefer to use GWT's DOM classes over the widget class. And we found, so if you look at Google Wave, you'll see we have these borders on our frames, big long blue borders. We actually used to use a 2-pixel wide image and just repeat it many, many times. And we found on Internet Explorer, resizing the panels was very slow. And a brilliant engineer back in Sydney, he accidentally discovered if we make that image instead of 2 pixels, 40 pixels. Wow, fast. So, you know, we've learned a lot of these very things we'd rather not have to learn. But we've learned tricks on how to make the browsers faster. Mobile. Thank you, GWT, yet again. We love Google Web Toolkit, if you didn't pick that up already. And with deferred binding, Google Web Toolkit made it very easy to produce the mobile version that we have so far. We use all of the same code, we just special case for mobile. So on mobile, let's use a different look and feel for the search panel. But otherwise, we didn't have to rewrite all of our code. So iPhone, you'd have to rewrite it in what's it? Objective-C? Yep. And on the Android, Java, we didn't have to copy all of our code across. With, I think it was half of one person in our team, we managed to get our mobile client working. So for version 1, we're shooting for an Ajax browser-based version only. And interesting bit of trivia, if you're interested, the iPhone browser is always running. So actually, we can get our application to start up faster by doing a web app rather than a native Objective-C app on the iPhone. We use a specific version of the communication channel for the iPhone, so it's a bit quicker. And we had an intern in Sydney working on hooking up App Cache, which you saw demoed at the keynote this morning. So using the database functionality of HTML5, so that if you're offline, which happens on a mobile quite a bit, and also getting the program to load faster. Turns out iPhone doesn't guarantee that anything bigger than 25 kilobytes will get cached. And you saw the graph, we're a lot bigger than 25 kilobytes. So we need to use the database and app cache. And just in case you forgot what mobile looked like, I've got the Android emulator on the left and the iPhone emulator on the right. And here's my China trip pictures, and Dan's online. But I'm going to reply to this. Do you like my pictures? He likes my pictures. And I think Dan's going to join me in a second. Oh, I noticed. That's why my phone jumped to the top. Yep, so you can see Dan sitting right here, but he could be sitting anywhere in the world. He's busy replying to me. And obviously, you've got to have a mobile version, but what's really neat for us is that we had to do so little work to get this going. Very easy thanks to Google Web Toolkit. It's the same code. Great. Okay, that's mobile. Now I want to talk about testing. Software developers like to write code, write features, and not write tests. And the reason we do that is we like to see things working. Turns out if you don't write tests and you're writing a big software application, things break. You write a feature and 3 months later it's not working anymore. So it's very important that you write tests and have computers automatically run these tests to see that everything is working. Some tips if you're going to use Google Web Toolkit. Use the Model View Presenter design pattern. You can read more about that on the internet. I wish we had known about that 2 years ago because our code is not as testable as it could be. Prefer using typical Java JUnit tests rather than GWT test cases. So what does that mean? A GWT test case actually fires up a browser and runs your code as JavaScript, whereas a JUnit test runs it as Java. The reason you should use a JUnit test rather is it runs in 2 seconds, whereas a GWT test case runs in 1 minute. And finally, it's good to have a mix of tests. You want little tests that test your individual units, but you also want big tests that test the whole system works. You don't want to have a million tests that all pass, then you load up the program and it's a blank screen. Nothing works. So I'll show you what we use. It's a tool called WebDriver. WebDriver is a developer-focused tool for browser automation. Has anyone heard of Selenium? A few nods? So Selenium is WebDriver will be part of Selenium version 2. And WebDriver actually is a test framework that loads up Google Wave, clicks buttons, types text, drags things, and then checks that everything is correct. This is really quite important to us because we don't want things breaking and we don't want to have to test everything ourselves. So we get the computer to do the testing. Why do we specifically use WebDriver rather than another tool? WebDriver has native keyboard and mouse events rather than what Selenium does, which is synthesize JavaScript events. We need this. There's certain things we couldn't test without WebDriver. Challenges, we adopted it very early, and the team is still quite small, so it wasn't quite complete. But Google Wave is committed to WebDriver. It's open source. I will put the link on my final slide, and you can learn more about it. And Google Wave, for every person that the WebDriver team puts on the project, we're going to match them. We'll add a person as well. What's coming? What's new? Well, we have iPhone driver, so I can now automatically run tests on an iPhone. See that our mobile version of the client works, which is great because it always breaks. So we need this. And remote WebDriver, so we can farm out our tests, run them in parallel on lots of different browsers, lots of different machines. And you probably want to know what this looks like, so let's give you a demo. What you're about to see, so I've just kicked off the process, run WebDriver. You're going to see a Firefox pop-up in my Linux machine. Here we go. And watch, types the username, types the password. It's just like you sitting at the computer, except the computer is doing this. Loads up Google Wave. Do you know your ABC and your alpha, beta, gamma? And then it adds a participant. And this test is actually checking that the title of the wave, so see here, do you know your ABC? This test is actually checking that the title matches the first line of the text in the wave. So now we can forget about that feature because we know that the machine is making sure it works. We don't need to worry about it. We can move on to the next feature. And this test, if I'm not mistaken, is going to show drag and drop. There we go. Test dragging contact. So this test actually tests dragging a contact. It's much too fast, which is good. But it shows dragging a contact from the contacts panel into a wave and checking that it gets added. So we have lots of these WebDriver tests, and they're really powerful. They allow us to make sure that our application actually works. And also it's nice, we leave this running up on a TV screen in the Sydney office, and we see this running all the time. So if somebody accidentally moves a button all the way to the bottom of the page, and we don't have a test for it, I watch the TV and I say, hey, the button moved. They're very powerful tests. Okay. What does a WebDriver test look like? Here's an example of an actual WebDriver test from our codebase. It's actually the very first one you saw running. And what we do is we have blip panel, get the focused blip. We call these little boxes in the wave blips. Gets the editor. It types, do you know your ABC? We just saw this. Presses enter. And your alpha, beta, gamma. Presses back. Types ... question mark. So we're testing backspace works. It checks that the text in the editor matches what we think it should be. And you'll notice here there's a little pipe character right here. This is saying to our test framework, make sure the cursor is here. And then we click submit and we make sure that the title matches what we think it should be. So this is an actual WebDriver test. Very easy to read. It reads a lot like English. And so some tips on writing WebDriver tests. Avoid using XPath. This is how you find the elements on the screen. So when I say get editor, it has to traverse the DOM and find the element. So don't use XPath because it's slow and it's brittle. Rather use IDs, names, and sub-DOM navigation. So if you have access to an element already, traverse underneath that. Make your intent of the tests clear. So make it read obvious. You know, I can read that test and I know what it's doing. And also the other tip is each UI class, so every class in our actual code should have a corresponding WebDriver class. So if you write an application, if you have a menu, you should have a menu WebDriver class. And that allows our tests to read much more clearly. So that is the content of my talk. Just to tell you what I just told you. I told you our decision to use Google Web Toolkit, which we think we made the right decision. Client architecture, the browser channel, and also the protocol buffers. Some of the changes that have occurred in Google Web Toolkit in the last 2 years. Improving gears, and obviously we're committed to HTML5 at Google, so we want to see browsers get much more powerful. Performance, we want Google Wave to look and feel as good as, if not better, than a desktop application. Push the browser to the limit. We have a mobile client, which we've shown you, and we want to make that better and better and better. And testability and WebDriver, how we make sure our application actually works tomorrow. Thank you very much. So I intend to publish these slides, and we've got lots of links. You saw links on all the slides. If you want to learn more about Web Toolkit, we've fortunately got Chinese slides, documentation, and also WebDriver. And if you want to learn more just in general about the magic, the technology behind Wave, wave.google.com. Any questions? Great. Enjoy your afternoon. Thank you.